Hello, welcome back to this channel. In this video, we will be learning about the projectile motion in fortran. Okay, and we will see the variation of the horizontal range of the projectile with respect to the angle of the projection. Okay, so before starting the course, we need to know the basic information about the projectile motion and projectile. For that, let's go to the browser and see some basic things. Okay, we have a blog also, so let's go to the blog. Okay, to go to the blog, you will just simply search, typing the smart learning to 020 and .blogspot.com. Okay, and press enter, and that the page will opens like this, and there is, you can see the option IT is smart learning. Okay, and just click on it, and the page opens like this. Okay, here we have a post called projectile motion in fortran, and the relation of the angle of projection and horizontal motion. Okay, you can see also your share button, you can share this post as well. You can also get the link or share to Facebook or any other social media, and there are 3 lines here, and you can just click here, and you can go to the Facebook page, go to our YouTube channel, and also you can search for the words using the Wikipedia, and you can search for the content of this blog from here, and you can also search the contents of this blog by using this category, content category labels. And for example, we have information related post with, there are 13 posts, and fortran post there are 8, and you can also change the language by clicking here. There are different languages, you can change to the language of your region or your language, and you can also search for the old post from here. Okay, it is you can search with the dates. Okay, in this way you can just visit this blog, please. Okay, and to see the whole post, you just need to click on read more. Okay, if you have any comment or suggestion, you can also comment by clicking on there, post a comment. Okay, if you click on here, it opens like this. Okay, and you can type here. Okay, and post the comment. Okay, now the post is opened fully. Okay, you just need to read the whole post, you just need to click on read more, and it opens like this. Okay, the link is provided in the description, you can go through that link. Okay, so now this is the plot graph of the projectile motion, and along x-axis it is angle of projection in degree, and along y-axis it is horizontal range. Okay, and this plot shows that horizontal range increases with increasing angle of projection. Okay, and reaches to maximum at about 45 degree, and horizontal range again begins to decrease. Okay, beyond 45 degree. Okay, and angle of projection varies from 0 to 90. Okay, so this is the basic things, and first of all, let's discuss a few things about the projectile. What is projectile? A projectile is an object thrown to the sky with a certain velocity against the Earth's gravity. The motion that projectile poses during its journey until it returns to the same surface from where it was thrown is called the projectile motion. Okay, it means the projectile is the object thrown from this point towards the sky with a certain velocity. Here the velocity is given as 30 meter per second. Okay, against the earth gravity, that is a 9.8 meter per second square, and it returns to the same surface. Okay, with some distance further from the point of projection. Okay, so this is the projectile, and the motion that the projectile possesses during its journey until it returns to the same surface from where it was thrown is called the projectile motion. Okay, and in above figure, the projectile starts its journey from the point O. Okay, it starts journey from this point and it lands on this point at this point. Okay, and this whole curve is called path of the projectile. Okay, we suppose theta as the angle of projection. This angle is angle of projection. Okay, this is angle of projection, and this this object is projected with a velocity u. Okay, and it possesses horizontal range r. Okay, you can resolve the velocity of projection along x-axis and y-axis. Okay, this is x-axis, this is y-axis, and the relation for horizontal range and angle of projection is this. Okay, u square times sine 2 theta by g. Okay, u and g are fixed constant. Okay, fixed values, so it is u and g are suppose as 30 meter per second and 9.8 meter per second square respectively. So from this relation we see that r varies with theta. Okay, and this variation gives this plot. Okay, there are other relations given as well. You can also see the relation between theta and h. H is maximum height, vertical height. This is maximum vertical height. Okay, if you draw the line from here to this point, from 45 to this maximum. Okay, this is the maximum vertical height of attained by the projectile, and this is time of flight. Time of flight means the time taken by the projectile from this to reach this point. Okay, this is time of flight. So now this is the fortran code. Okay, I will show you typing this code and we will generate the data, and after generating the data we simply plot that data by using the gnuplot, and the output will be this. Okay, we will go up to this. Okay, now let's move to the fortran. So please visit this site. Okay, now to start the coding, start writing code, let's go to a folder. I have created this fortran folder and just click on here and it opens like this, and there are a few files I have created in previous videos. In this video let's click on here and choose the option open in terminal. Okay, I want to create here a fortran file. Okay, let name this file as, I will write the code using gedit text editor with the file of the file name is projectile dot, let it be f90. Okay, just click on OK. The gedit opens like this with the file name this. Okay, here I want to write the code for generating the angle of projection versus horizontal range data set. Okay, so to write the code, first of all we need to name the program. Let it be projectile motion. Okay, simple name, and there will obviously be implicit none. Okay, then we need to define integer. Okay, let this integer be theta, and we define real variables as this will be as angle. Okay, and r. Okay, and also real parameters. Real parameters will be this will be value of pi. We need to use pi. Okay, and pi will be given by this formula. Okay, 810. Okay, and obviously velocity of projection is 30 meter per second. 30 meter per second. Also acceleration due to gravity is 9.8. Okay, so this will be the parameters. And we use do loop to write the code. So theta is equal varies from 0 to 90, and we need to change this angle. Okay, and this is theta is angle in degree. We need to convert it into a radian. Okay, so to convert the angle in degree to radian, we simply multiply theta by pi by 180 degree. Okay, and then relation for horizontal range is equal to u square, let it be bracket, u square into sine 2 times angle. Okay, and then it is divided by g, and after that we print, or we print theta angle and r, and do and program. Okay, just save it. So this program will generate the data theta and r. Okay, now let's check the code whether it is correct or not by running on fortran. Okay, so to run the code, just type fortran and then type the file name. Okay, and press enter. Okay, there are some mistake here. This is a 10, actually I typed it as t and a little bit 10. Okay, now the program will be correct, I think. Okay, it is correct now. To see the output, you just need to type this much and press enter. Okay, so this column contains the angle in degree, and this column contains the horizontal range in meter. Okay, and angle varies from 0 to 90. Okay, to plot the graph between this column and this column, we need to save this. So let's save this data in the data file. Okay, for this we use open command. Okay, with unit 1, file name be, let it be projectile.dat, and action will be to write the code. Okay, and we need to add here also command write 1, and obviously theta r is to be written. Now we close the open command. Okay, so this displays the output on terminal, and this is this code writes the data of theta and r in this file. Okay, now let's save it and see. First of all, let me show you, there is no any .dat data file. Okay, after running the code on fortran, you will see data file there. Okay, okay, now it has data file. So let's open it, and it contains the angle versus horizontal range data. Okay, we need to plot this data using gnuplot software. So now let me okay, so we need to create another file here. Okay, so let it be created from here, and here we need to write the code, gnuplot code, to plot this data. Okay, so simple, the code will be plot. Okay, projectile.dat. Okay, using column 1 along x-axis, column 2 along y-axis with line point. Okay, projectile.dat using line point. Okay, just save it, let it be projectile projectile dot, and it will be with gnu .gnu extension. Okay, you can also use .p. okay, and to save it. Now this file is saved with projectile.gnu. okay, now we need to load this code in gnuplot to see the graph. okay, first of all we need to load the gnuplot software on terminal. For this, just type gnuplot and press enter on the same folder where the code has been saved. okay, now to load that code on gnuplot, you just need to type load and file name. okay, edit with this and gnuplot, just this much. okay, after typing this mouse command, you just need to press enter, nothing much, just press enter and you will get the output like this. okay, this is the plot, this is legend, and this x-axis, y-axis, this is angle in degree. okay, and this is horizontal range in meter in degree. Now we can modify this graph, we can add title, we can change this name, we can add x level, y level, and we can also change the thickness, we can add grid on this plot. okay, so let's do that, some modification here. okay, let me add title here. The title will be angle versus range. okay, angle in degree, range in meter, and set x level will be angle of projection in degree. okay, set y level, this will be horizontal range in meter. okay, and then also set title. The title will be projectile motion. okay, with u is equal to 30 meter per second and g is equal to 9.8 meter per second square. okay, and let's run this mouse code first. okay, if you load the code again and see the plot, now it looks like this. okay, we have title, we have horizontal range, we have angle of projection in degree. okay, and this also change. We can also change the range of x-axis, range of y-axis, and thickness of plot. Let me change some here. So set x range. okay, x range is angle, so it will varies from 0 to 90, and set y range. okay, see y range from where to where. okay, so y range starts from 0 and it goes up to 9 plus. okay, less than 100, more than 90. so let's set it as 0, 95. okay, and then okay, from here we can see the line color as 10. okay, there will be line width as 2 and line type will be 8. okay, now let's run the code again, load the code. okay, there is some mistake, projectile line undefined variable title where. okay, this is not comma. okay, save it and plot it. now you can see the difference. okay, So now x range is from 0 to 90 and y range is from 0 to I think 95 up to 95. Okay, this is the plot. This is angle of okay, horizontal range versus angle of projection, and it opens like the plot looks like this. And this is if you draw a vertical line from this point to this point about 45 degree, then this height is maximum height attained by the projectile, okay, when it is thrown from this with a velocity 30 meter per second square. And this is also called the horizontal range, okay, but it is in this case it is angle, okay. And because the object is projected from here and it lands on this point, so the distance between this point and this point must also be horizontal range. Let me show you how to write this line, this projectile motion in one line, and this mass in another line, okay. For this, what you need to do is just after this motion, make sure here the double quoted bracket first, and after motion you just need to type backward slash and n, okay. This will go in next line. Just run the code again and see the result by refreshing. Okay, now it is here, okay. So in this way you can visualize the projectile motion in fortran, okay, by generating the data. Similarly, you can also check for angle of projection versus maximum vertical height, and angle of projection versus time of flight, okay. And just try yourself, okay. It is very interesting. And this is the code for the plotting data. I will provide these codes and all these files in the description, okay. You can just visit the blog, okay, that I have shown you before, and visit the blog and download all papers, okay. So thank you so much for watching. We will see you in next video. Stay watching, stay connected with us. Please don't forget to subscribe the channel, and if you are new, and like this video, comment, leave the comment on the comment section if you have any queries, and share it with your friends. Thank you.